chemical bonding. In order to understand chemical bonding, you've got to first have a reminder of the structure of an atom. And last year in C1, and when you were doing your revision for your exams, for these C1 exams, you should have revised that we've got a central nucleus that has got protons, positive protons and neutral neutrons in it, and orbiting around the outside, orbiting the nucleus in shells, or energy levels, we've got the electrons. And what we also learnt about last year was the fact that those shells can only have a certain number of electrons. So the first shell can only have 2 electrons in it. The second shell can have up to 8 electrons, the third shell up to 8 electrons. And we can write out an electron configuration like this, where we've got the number 2 for the first shell, 8 for the second shell, 8 for the third shell. Someone in 10SC3, I think it was, came up with a brilliant way of remembering 288. She used the bingo call, 2 fat ladies. So when you call out 88, in a bingo hall, the guy will go, 2 fat ladies, 88. And if you look, we've got 2 fat ladies. Genius. So if we're filling up the electron shells, then we should remember 2 fat ladies, 288. Fantastic. There you go, see, 2 fat ladies. So, if those of you that are not filming, if you look at your periodic tables now, if you have a look at lithium, lithium has got an atomic mass of 7, but today we're going to be looking at the small number, which is its atomic number, and you'll see lithium has an atomic number of 3. And this atomic number gives us a fantastic amount of information. For example, it tells us that lithium has 3 protons in its nucleus. And you can see there, 1, 2, 3. If an atom has 3 protons, then we know that it also has 3 electrons. And you can see on our atomic diagram here, we've got our 3 protons in the nucleus and our 3 electrons orbiting the nucleus. And we also know, because you can only fit 2 electrons in the first energy level, or the first energy shell, the electron configuration will be 2 in the first shell and 1 in the outer shell. So 2, 1. And the last brilliant bit of information is, if there's 1 electron in the outer shell, we know that that atom is in group 1. So just from knowing the atomic number, we can start to deduce loads of other really useful information. I'll do a second one for you. This is oxygen. If you look in your periodic tables, you will find that oxygen has an atomic number, remember the lower number, of 8. So going through the same things, this tells us, number 1, that oxygen has 8 protons in its nucleus, 8 positive protons in its nucleus. And therefore, it has 8 negative electrons orbiting around that nucleus. And again, we can only fit 2 electrons in the first energy shell, so the remaining 6 must be in the outer shell, giving us an electron configuration of 2, 6. And guess what group oxygen is in?
6.
It's in group 6. 6 electrons in the outer shell, it's in group 6.
Yes.
Last one that I'm going to do for you, magnesium. And again, look in your periodic tables, it's got an atomic number of 12. This means it must have 12 protons, and therefore it must have 12 electrons because it is an atom, and therefore we fill the first energy shell with 2. We can only fit 8 in the next energy shell, so that means it's 2, 8. But that's only 10 electrons, and we know that magnesium's got 12 electrons, so the final 2 have to go into the third shell, giving us an electron configuration of 2, 8, 2. What group must magnesium be in? 2. It must be in group 2. Fantastic. So, here is your task.
Yes.
1, 2, 3, 4, 5 different atoms. I would like you to use your periodic table